Anyway, so OpenSCAD. What time is it? No, have a.
It's 10 past 1.
10 past 1. Marvellous. Run through this in like 30 seconds and then I'll go and eat a sandwich.
Right.
So, I'm not an OpenSCAD expert. I'm presenting my experience, which is mostly limited to 2D design with a little bit of tinkering with 3D stuff. So, if this, although I believe that the principles of the 2D stuff apply to 3D stuff. So, why choose OpenSCAD? Because it does absolute positioning and sizing without a lot of fucking about. It's programmatic, it works on most operating systems, and I really hate graphical tooling. Really, with a passion.
What do you mean by that? What's graphical tooling?
So anything where you have to drag and drop or position things graphically, I just can't stand it.
Right, okay.
It just gets on my nerves.
So Blender.
I want to say, I want it there. I want it this big.
Yeah. Use Blender, write all in Python.
So, in terms of versioning, there are OpenSCAD's been around for a while now, but 2015-03 adds supports for text. So if you want to actually put text on anything, use that version or greater. And there are 3 versions of 2015-03, which is great. But they all seem to have the text support. So this is what it looks like. And it's kind of, there's not a lot there to start with. But we put code there, we end up with a preview there, and our output errors from the compiler end up in the bottom right. Let's take a simple example. We can create a cube which is 10 by 10 by 10, and we're saying center equals false. And what center equals false means is that the origin of the object, it can be the center of the object, or it can be the bottom left corner, where you would expect the origin to be. So there we go. That's what we get. Very straightforward, really. So the preview pane is a little bit of a pain. Like Tom said, if you're trying to do CAD without a mouse, then you're in for a world of pain. So the left mouse button in OpenSCAD allows you to move in 3D space, so you can rotate around an object and do that sort of thing. The right mouse button allows you to move in 2D, so if I actually show you this, it'll probably make slightly more sense. So we look at the LAN printer shelving, which is behind you. So if we do right button, we can do moving on the same plane. If we do left button, then we can rotate it and move around it.
And middle button does zoom, right?
Yes.
Which was the so next.
Scroll wheel to zoom in there. And let's talk about some basic 2D shapes. So we can have square. Square and cube are special ones because you can just give it one number because it's equal on both sides unless you actually don't want a square, in which case you use the square and tell it what size you want. Again, you get the option of center to say whether the origin is in the middle of the object or at the edge. Same with circle, and in the newer versions you can specify diameter in addition to radius. That was always a bit annoying, the fact that you have to specify radius in the older versions, so use the newer version. And we can combine these things. So we can position with translate to say where you want your thing. So in this instance we're putting it at x coordinate 10, y coordinate 20, and we're giving it a diameter of 30, and you end up with that, which is very straightforward really. We can also add more than one circle, so in this case we're adding a bad example that doesn't work. Because that's 2 on top of each other. But I should say
Copy paste.
yeah,
Blender.
yeah, that should say 50, which is what the example says.
It's fine, they don't hear.
So yeah, you can put 2 circles next to each other. So you've got the translate option, which allows you to position it. And obviously we're only working in 2D space at the moment, so we're only doing X and Y.
One of the things that I really like about OpenSCAD is that you can always see the axis, and you can even have a ruler out of it if you turn the two buttons to the right of the one already depressed.
These?
Yeah, these two, yeah. You'll have your XYZ with colors, and you can have the ruler which gives you that. It's nice because when you're looking at translate, you see an object in the middle of the screen. But if you put the axis, you can visually see. Oh, I moved it from the origin, which is the intersection of those three lines. If you have something in the center of the object will be in the center intersection of those three lines, the three axes.
Cool. So, and what we can then do is we can use combinations of those objects. So difference, we can draw a large circle and then remove a small circle from the middle of it, and we get that.
A washer.
Yeah. So again, all of this is 2D, but exactly the same principles apply. So that's a more complicated example. Some of you may recognise that as the glass gate from the design that I talked about recently. So that's only one part of it, but basically you've got a big square and you're taking stuff out of it to make holes.
Somehow your what is it called?
Text?
No, the circle is not a circle. It's oval?
It's the monitor.
It's the monitor.
Yeah, it's the screen. The ratio is wrong for the screen.
Ratio. That was.
Yeah.
Yes.
It's not 4:3, whereas my laptop is.
Is it 16:9?
So I guess.
Yeah.
PlayStation.
Yeah.
So it looks wrong, but it's fine on mine.
What are you on about?
Where am I? What is that?
for
It
me.
works for me.
Is that on the screen that none of us can see?
Yeah, that's right.
Yeah, that one.
Okay, so there are other combinations of things you can do with OpenSCAD. You can do union, difference, intersection, and render. I have to say the only one I've ever used is actually difference. Never had any of the others.
What does render do?
I have no idea.
Okay.
Render is for changing colours, and also rendering out the final object, so
No,
you
it's
can do high quality stuff as
Isn't
well.
it for like keeping an intermediate construction of like an object that you don't want to be somehow?
I'm not sure. As I say,
Yes.
my experience with
No,
OpenSCAD.
it's like it gets to a certain point and then you put a render instruction and it says store this as a mesh, and then you can do more things to it afterwards or something.
Yeah.
My experience with OpenSCAD has been limited to fairly basic, just
It
2D,
truncates
3D
the
designs.
tree of like it saves it from it's for optimizing calculations, so somehow it doesn't have to go into all the finer details of how a particular thing's made. I think I can't remember, something like that. But I'm not sure if that makes any sense. Actually, what I'm saying, I've just got a vague feeling it's something like what I'm talking about.
It's yeah. If you've got like a sub-assembly, you can render it inside the same file, at which point, if you don't change it, it doesn't need to recalculate
That
it, so
kind
it's
of thing.
quicker.
Yeah.
And also, if you've not got a powerful graphics card, you're not trying to render everything and your graphics card doesn't fall over from lack of memory.
Yeah, it's that sort of thing, I'm pretty sure.
So, as I say, my experience with OpenSCAD is actually fairly limited. So.
Okay. From one of the things that I like on the OpenSCAD site, they now have a cheat sheet.
Yeah.
And I went
That's
there.
actually really useful.
Yeah, I went there and clicked on render, and the wikibooks, which is the documentation for render, says forces the generation of a mesh even in preview mode. Useful when the Boolean operations become too slow to track.
Right, yeah. Oh, I see. It's a bit like what I said.
So other 3D objects are cube and cylinder. There are other things that you can do with it.
Can you do toruses?
Don't
Yes,
Mm.
you
The-
can
the
do torsos
documentation
by
on Wiki
rotating a circle.
Oh, okay, yeah.
the documentation on the wiki is actually really good.
Yeah.
So there's a pile of links to bits and pieces of hardware designs, and also the Wikibooks one that Gus has mentioned.
Yeah.
Everything links from OpenSCAD.org, so it's the best link to write down.
That's pretty much it. That's all I prepared. Because, you know, I didn't really have time to do a massive amount of preparation. So, if we want to talk about, so some of the things that I've done are the LAM 3D printing shelving behind you, which is all just, you know, yeah. So you can see you can do different colours and intersections of parts and things like that, basically to give yourself an idea of what's going on with the design before you actually build it.
Okay.
So I've tended to use it for that sort of thing.
So you were saying about what union and intersection for. You can see where you've got the intersection of the. If you scroll right in, you can see it.
Yeah.
If you used union, that would make those two one piece. If you used intersection, it would leave you just
from the other.
it would leave just a bit that overlaps, and that's a really annoying fly.
No, to be, if we turn the lights off, it might find its way out, possibly, because it's going to be attracted to UV.
There we go.
Oh,
See, that was amazing. That was so fast. So fast.
Thank you, Tom and Andy.
Victory.
So yeah, I mean, some of the things I've done basic designs for drill control panel for my drill at home, and then the more complicated stuff that I did for Blastgate, which was a full design, which looks fucking
you
awful.
did the Longworth truck as well.
I did. That was both me and Tom actually worked on the long one.
That sort of worked as well, didn't it?
No,
No.
because I fucked up the implementation. So.
The maths on it is kind of horrendous.
No, it wasn't maths in the actual system. It was when he cut it, he didn't, on the laser, he forgot to unite the
So you ended up
circled
with
lines.
lots of little bits.
Yes, it was, yeah.
So that's the sort of thing.
That's one thing with OpenSCAD is when you export circles, they end up as
Lots
lots of lines.
Yeah, one of the
in
things you
export
forgot
format.
to mention is the FN, FN, $FN. It's it's a global variable that defines how many segments you have on a circle. I think it's segments per
depends on the
angle.
one. FN is number.
Yes.
FA is angle.
Yeah, that's it.
So on a circle, if you say have an FN of 6, you end up with a hexagon.
Yes.
If you have an FA of 90, you end up with a square.
Not radians.
No, I don't think it. Actually, is it right?
It's angle. I'm
You'd have
not
to look
sure.
it up. It might do both.
What I
You might be
usually
able to
do
degrees.
is
Wouldn't
I
surprise me
put
if it's
FN at 200 and it gives me really nice circles when I export to the STL.
Yeah.
I've been doing some fidget spinners on OpenSCAD.
so FN 200 works.
FN 200 makes it really small. I think FN
Not-
100.
Not FM 200, which is fire extortion.
No.
Um,
And it's $FN.
yeah, it does slow down your render
Yes,
time
of course.
considerably. So
Yes.
have it on a low number to begin with, and then when you got it roughly right, bump it up again.
I think the FN perfect one for perfect circles would be 360 because I think it's the number of segments per angle per.
It's in
I'm
degrees.
probably talking out of my ass,
There you
but there you go. Minimum
Minimum.
angle. FN minimum angle in degrees of each fragment. So if you put 1 or 360, you'll have 1 degree. I think.
That's the minimum angle. If you put 360, you end up with a dot.
Yeah.
If you
No.
put 180, you end up with a line.
Probably. I don't know. Oh, wait a minute.
That's
FN,
pretty-
fixed
like
number of
Yeah, yeah.
segments in 360 degrees. Ah,
That's the one you're talking about.
yeah, that's the one I was talking about. Sorry.
Yeah.
Yeah.
So it doesn't relate to 360.
So that determines how many straight lines you end up with in a circle to
Yeah.
basically draw the circle.
Yeah.
So the more the merry. If you want to export to something like 3D
exactly.
printing.
Yeah, that makes sense if you understand the fact that a circle in a computer is not a circle.
So again, this
It's
is
a lot of straight lines drawing,
Um,
creating what looks like a circle at a certain angle.
So when sending
Yeah.
this to the
Let's not go into DXF.
laser cutter, I can use DXF, export it from DXF, and then import it into the laser cutter software as DXF.
So you okie dokes. One of my things was if I ever did an export, I would do XDL and then. Oh, never mind. I was thinking about Inkscape.
STL normally for 3D printers, and
Yeah.
DXF for graphics.
DXF for the.
The vector graphics.
Yeah.
One nice thing, one really nice thing about OpenSCAD is it's one of the few things I've done that we don't have to go through another program to get it to the laser cutter.
Right.
You can go direct from the DXF out of that directly to the laser cut software, and it's got
Works.
no issue, no sizing or anything.
Right.
I didn't go over that on Fusion actually.
Does
but
that not
it's-
apply to Inkscape?
Inkscape has some issues.
Right.
The export to DXF, you have to specify if it's the robot thingy-majiggy or the other thing.
There's no, you specify none of it, but there's still both. They've got sizing issues in Inkscape and DXF and all that. So yeah.
Cool. Well, that's pretty much me. I didn't really.
What's that model?
That is for a. You cut two of these designs
Yeah.
and you flip one of them,
Yeah.
and then where the lines are, the arcs, you
Right.
put bolts through, and the two sit on top of each other, and you rotate the whole thing one against the other,
Yeah.
and it brings the bolts in and out.
Right.
And it's designed to go on a wood turning lathe,
Right.
so that you can put a bowl in it.
Oh, I see.
So it's a
So-
chuck.
It's a Longworth chuck is the design. So basically,
Right.
when you take your bowl off, you can put it bowl open end first onto
Yeah.
the Longworth chuck, clamp it, and then turn the bottom, because you can't turn the bottom any other way. So,
Oh, you put that, you clamp it on the inside of the bowl?
no, it
On
goes
the
on the
outside.
open end,
Right.
so
I see.
so you can actually
Yeah.
work on the bottom of the bowl, because
Yeah.
otherwise you can't work on the bottom of the bowl.
Well, it's kind of like an iris.
Yeah. I see what you mean. Yeah.
Yeah, it's when you've got the tenon and you want to take the tenon off the bottom of those.
Right. Is the tenon the bit that you had that was anchoring the
Yeah,
bowl
the
to
tenon
the
is
blade?
what you
Yeah.
chuck in on a normal chuck when you're taking the centre of the ball out.
So there you
Right.
go.
In fact, that's the old one, isn't it? On the bottom, that bottom left.
No.
No, that's not it.
No, that
It
was
looks
what,
very close.
that was what we were trying to achieve. But
Yeah.
we didn't quite manage it because.
The curve maths is not easy.
And it wasn't right.
No.
So,
Cool. Yeah, that's what we were trying to do. Didn't quite work out.
yeah.
Wasn't far off. I think with a bit more effort, we could have probably got there.
Well, it's a digital file. We can still throw it back at each other a few times.
Why don't you just make someone else's and try selling it?
Because I wanted to do it mathematically, so I could chuck numbers in it and actually be able to generate one of whatever size.
Yeah,
You can't trace in OpenSCAD, unfortunately.
that would be a good argument. Yeah.
Depends what. The biggest thing I find with OpenSCAD is if you've got a programmer's mindset, it's really easy. If you haven't, then it's a good way to learn to program and learn some of the different ways, but it's also not the best way to learn to program because it's got some really weird stupidities.
It's quite different from other programming languages in the way it works.
If you can break down your 3D piece into the basic shapes that OpenSCAD gives you, either the 3D things, which is cylinders, spheres, cubes, or the 2D things that you can then extrude, and OpenSCAD even has a polyline, so you can even do polyline stuff. If you can mentally break your 3D piece into small pieces that fit that you can then either add or subtract, or even if you have something that you can intersect, like you have a triangle and you have if you want to do an arc thing, I think you should use a triangle, and two circles. So you can have a washer, a section of a washer, like a section of a washer, and then that works. And the other thing that I like about OpenSCAD is the fact that you if you get it early on and you put all your variables on the top, all the variables that you can think of at the top, then you always use it exactly. That's I picked it from you, Ian. Then you use only variable names instead of numbers. You try to. The only thing you would probably do is like multipliers. Like if for some reason you're stuck in a version where you only have radius, you put a variable saying circle R, and then you put a variable underneath which is circle R times 2, and then you have and then when you have your whole thing and you say, oh bugger, this needs a millimeter off or in or out, you just edit that variable and press F5, boom, you have a preview. That's one of the things that I'm missing in FreeCAD. But in FreeCAD you have a spreadsheet like Andy told me, and you can import a spreadsheet from Excel or something like that, or you can create a new spreadsheet and then you put all your values there, and then you say this cell, this number cell has a name, and it registered in the global variable thing, and then you can use that in FreeCAD. It's the only thing that I really love about FreeCAD is once you get your mind around the fact that you can put all your variables on the top, all your numbers that you're going to use on the top, and then you build all your 3D model around those variables, which makes more sense, because a number is a number is a number. Something a name is something more relevant than just a number. And then apart from the easiness to remember, what was that thing, that number that I needed, you don't need to remember the number, you just need to remember the name that you give to the number.
Thing to note as well is if you know OpenSCAD and you upload your files with a couple of extra variables in to Thingiverse, which is a 3D storage website, you can actually set which of those variables are available outside of it and do customizable objects from the website that you just download. So say you want to change the name in it, you can just type name into a customizer, press get, and it will send you the model. So you can script changes to these really easily.
One of the great things I really like about it is because it's text file driven, you can version control that.
Yeah, that's
Oh,
very.
You can actually diff it,
Yeah.
see what you've changed and why. So I actually really like that aspect of it as well, which makes publishing the design.
I wish FreeCAD had my ideal 3D environment design program would have a system where you can work in the graphical interface if you want to, but everything you do in the graphic interface translates into operations in a base code description that's stored with the model, that's kept with the model, and then you can version control that, and you can code directly in that if you want to, or maybe you can do some things in the code level that are actually more complicated than you can do in the visual level, but you see what I mean? Yeah.
I mean,
One of the
I
things,
haven't found anything like
actually, FreeCAD uses a tree model. So everything you do is then translated into a tree, and everything branches out. If you do one of those sketches, the sketch will appear in a tree. That tree, if you then apply a modifier to it, it will branch it out. You'll have the whatever modification that you'll do, and you click the little plus, like in the folder structure we have in File Explorer. You'll see that the sketch is there under the transformation that you did, and when you get to the end of your 3D object in FreeCAD, there's a humongous tree done. So I don't know why they don't translate that into a JSON file format, something like that, because it's quite easy. The transformations are all parameterizable. So laziness probably, or nobody actually thought that they could make it Git friendly, or version control friendly. I don't know. one of the things that pisses me off is the fact that FreeCAD has a compressed format for their files. So it's a binary. If you want to put it on Git, it will be a binary, and it's a blob.